So now we're going to take a look at the packet that you have titled Optimization Problems. Each video is just going to be one problem. And again, hopefully when you go to the homework, you can kind of match up these examples with specific homework problems. And the process that I already described is just listed over there. Let's take a look at problem number 1. Take a moment and read problem number 1. Okay, there are a couple different ways we can set this up, but it's actually going to be easiest if we make x this entire side and y over there. We need a primary equation. What's your primary equation going to be? I want to maximize the area. Give me a primary equation. Since I want to maximize the area, area is going to be my primary equation. A equals just x times y. Next, they're telling us there's 120 feet of fencing available. That's going to give me my secondary equation. See if you can come up with the secondary equation. Well, let me see. I've got 2x. I've got 3y, so 2x plus 3y equals 120. Wow, this is very focused. One more moment. Sorry, that's out of focus. Don't know why I called that 2x. That's just x. I've got x on the top, x on the bottom, y, 2x plus 3y equals 120. I need to solve this for either x or y and plug it into my function. Doesn't really matter. Why don't we solve it for x and plug it in so I get a function with just y's? That's totally valid. Take a moment, solve this thing for x. 2x equals 120 minus 3y. Divide by 2x equals 60. Minus 3 halves y. I'd like you to take a moment, plug that in for x, and create your area formula just in terms of y. That's totally wrong, sorry. A equals 60 minus 3 halves y times y. A equals 60y minus 3 halves y squared. Next thing we need to do is find the derivative and get our critical value or critical values. Do I want to do that right now? You know what, I take that back. Before we do that, let's talk about our domain. I know that x has got to be greater than or equal to, actually I don't care about x here, I care about y here. I know that y has got to be greater than or equal to 0. What's the absolute most that y can be? I think, let's see, because I've got 120 feet of fencing, if I do 120 divided by 3, this could be 40, this could be 40, this could be 40, and that would leave me nothing for the other dimensions. So I think that's the idea. I think y has got to be in between 0 and 40. Now, go find your derivative of a and tell me what the critical value or values will be. Looks to me like I have a critical value at y equals 20. So now we're going to go set up our candidates test. Make sure whenever you're using the candidates test that you label your columns. Here it's going to be y and a of y. I need 0, I need 20, I need 40. I think it should be obvious what 2 of them end up being, but you do still need to show it. And how about you plug into either this version of A or this version of A and find those. know if I plug in 0, I get 0. Over here, I'm going to get 60 times 20 minus 3 halves times 20 squared. Here I'm going to do 60 times 40 minus 3 halves times 40 squared. This one will give me 600. This will give me 0. I know it should have been 0. I was looking for a maximum, so I think I've got a max there. I wanted to know the dimensions. So my dimensions are 20 feet by, well, to find the other dimension, I'm going to plug into 60 minus 3 halves times 20. I think that's 60 minus 30. I think that's 30 feet. The dimensions of the corral that will maximize the area, 30 feet over here, 20 feet over there.